Okay, let's prove the left and right hand side of the trigonometric function. Okay, we have to prove that this left hand side is equal to this right hand side by applying different trigonometric identities and properties. Now it's easier to just expand the trigonometric function instead of contract it. So let's take the left hand side. Let's prove that this sine 45 plus alpha is equal to this 1 by under root 2 into sine alpha plus cos alpha. Okay, because you can see that this looks very familiar. This left hand side looks very familiar. Yeah, we can apply the trigonometric identity on it. We can write down sine 45 plus alpha as sine 45 cos alpha plus cos 45 sine alpha. Okay, at this point you should know this. And as you know that sine 45 is equal to 1 by under root 2 and cos 45 is also equal to 1 by under root 2. Okay, now we write that down and you have this. And very simply you can take this 1 by under root 2 common from this term and this term, and now you've proven that the left hand side is equal to the right hand side, right? It's very easy. Now let's look at the sum of tangent functions. Again, we have to prove that the left hand side is equal to the right hand side. Okay, now obviously in this particular case you'll take the left hand side and we'll prove that it is equal to 0, because again, expanding 0, there are just a million ways to expand 0. It can be equal to 1 minus 1, 2 minus 2, I don't know, 3 divided by 0 divided by 3, and so forth. So yeah, you take the left hand side in this case, and let's prove that it is equal to 0. Now you have this again. Now look, it looks familiar, right? This and this, it looks familiar. You can apply the trigonometric identity of the tangent function on it. Now tan pi by 4 minus theta, it can be written down as tan pi by 4 minus tan theta plus over 1 plus tan pi by 4 tan theta. And again, you apply the same identity on this tan 3 pi by 4 plus theta, that is equal to tan 3 pi by 4 plus, right? Because over here it's minus because this is minus, and over here it's plus because this is plus, right? And at the denominator the signs are just inversed as well. Okay, now this is equal to tan 3 pi by 4 plus tan theta over 1 minus tan 3 pi by 4 tan theta. Fairly simple. Now let's see how it becomes 0. Now as you know, tan pi by 4 is equal to 1, right? And tan theta is as it is, and again this tan pi by 4 is equal to 1, so this entire term just becomes tan theta. So you have this tan theta. Okay, tan 3 pi by 4 is equal to negative 1, right? And tan theta is just tan theta. And again, you apply this negative 1 over here, and this negative sign multiplied by this negative 1 becomes a positive sign, and you're just left with this tan theta over here. Now, you can just take the LCM of this and this, it's just equal. So now you can just add the numerators up because the denominators are equal. So it becomes 1 minus tan theta minus 1 plus tan theta. You can subtract this, these ones, you can subtract these tan thetas, and so you get 0 over 1 plus tan theta, which is simply equal to 0, and hence you've proven the right hand side.